This is a video from section 1.5 in a linear algebra class. Definition. An n by n matrix is an elementary matrix if it can be obtained from the identity matrix I sub n by performing a single elementary row operation. Okay, let's take a look at this example. Which of the following are elementary matrices? Now, let's take a look at part A. Suppose I give you the matrix 1, 0, negative 5, 1. Can I get the identity matrix back by performing a single elementary row operation? And I would submit to you the answer is yes. Why? Because if I take 5 times row 1, add it to row 2, I'm going to put the result back into row 2. That's one operation, and look at what I get. I get 1, 0, 0, 1. And that's the identity matrix. So, therefore, the matrix 1, 0, negative 5, 1 is an elementary matrix. Okay. Let's take a look at another one. We'll call this part B. Suppose I have the matrix negative 5, 1, 1, 0. The question we need to ask ourselves is, can I get the identity matrix with one single elementary row operation? And remember, let's talk about it. So if I take 5 row 2, add it to row 1, and then put the result back into row 1, let's check out what we get. We get 0, 1, 1, 0. Well, that's not the identity matrix. So if I take row 1 and swap it with row 2, I do get the identity matrix, right? So I get 1, 0, 0, 1. And since it took 2 operations to arrive at the identity matrix, what that tells me is that the matrix negative 5, 1, 1, 0 is not an elementary matrix. Okay? I hope that's okay. And then let's take a look at C. Suppose I give you the matrix 1, 0, 0, square root of 3. Can I arrive at the identity matrix with one single elementary row operation? The answer is yes, because if I take 1 over square root of 3 row 2 and put the result back into row 2, I'm done. Notice how I get the identity back. And so, therefore, the matrix 1, 0, 0, square root of 3 is an elementary matrix. And then let's take a look at D. Suppose I give you the matrix 0, 0, 1, 0, 1, 0, 1, 0, 0. This is a great one because all I have to do is take row 1 and swap it with row 3. When I do that, I get the matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. And so, therefore, 0, 0, 1, 0, 1, 0, 1, 0, 0 is an elementary matrix. that's how we do that one. And that'll conclude this video for section 1.5. We looked at the definition of an elementary matrix and looked at 4 matrices and determined whether or not we had an elementary matrix or not. Okay, thank you.